Morning, guys.
Morning.
So that I didn't have to cancel. So sorry for those of you who are watching on YouTube. We're just going through the quiz. But yeah, thank you for reminding me, Mabel, because I had forgotten. Okay, cool. So yeah, nicely done, guys. So for each is correct. Yeah, that's how we iterate over an array. Again, you can use a for loop or a while loop to iterate over an array. You could, but when you're asked which structure should you use, if you're iterating over an array, you definitely should use a for each loop because it's designed specifically for that. Especially that it says each item should be processed once. That's exactly what a for each loop will do. Which of the following languages is not considered a high-level programming language? Which of the following is not considered high-level? So I mentioned this super briefly. It's almost, but even in seeing the question, it's almost like we're studying. So yeah, it's a good potential to study as well. Okay, since there's like 20 seconds left, I'll give a little hint. C# is a high-level programming language. This one was a mean one, I think. But it's a good way to study, so it's okay. Let's see what people were saying. Interesting. Okay. Cool. All right. So yeah, the answer is common intermediate language. I didn't expect you guys to get this one really, but this is something they can ask, and so it's definitely worth us spending some time on it, even if it's in this mean way. So C# is a high-level programming language, and in fact, the entire what we call the C family of languages. So C, C#, and C++ are all considered high level. So if you're ever asked about that, they're all high level. Python is like the highest level. It's the most abstract possible language. And for those of you who are newer, high level means that it's not binary. Okay, so like it's further away from actual machine code, right? Like a computer will actually, it'll perform its logic in binary, right? So ones and zeros. And the further we move away from that, we call that abstraction. And the highest level programming languages are the most abstract. So Python is one of the most abstract languages around. Yeah, C++, it's a part of the C family, so it's also high level. Some other high-level programming languages that you probably should know the name of: Visual Basic, Java, JavaScript, Ruby. All of these are high level. Common Intermediate Language and Assembly Language and Fortran are all considered low level. Okay, so yeah. Again, it's something that you just sort of pick up as we talk about programming languages more, particularly when we get to chapter 4. I think a lot of you guys will understand what's going on here more. But yeah, for now, you can think of like if there's a lot of English words like for, while, if, all of those kinds of English words inside the language, and they're used in a very abstract way, then you can think of it as a high-level language. Okay. It was just worth putting it in there so that we could have time to discuss it. Okay, on to the last question. I think this one is not timed. Yeah, so you can take your time on this one. All correct answers give max points. You write the following code: int x equals 5, int y equals plus x, int z equals y plus plus, what will the value of the variable z be after all the above code executes? This, I think a lot of you guys would have forgotten this because we did cover it 2 weeks ago. So I did want to do this quiz last week. Oh yeah, unable to join the MTA. We might spend a little, someone did ask me about this in particular after the lecture. So we will spend a little bit more time discussing what's going on this one, and then we'll continue. And we should finish off chapter 1 today, so that's cool. Okay, 3 answers. Let's see. Okay. We were interesting. Okay, so the correct answer here is 6. All right, 6. So I want to. Okay, someone said y plus plus. Interesting. Okay, let's spend some more time on this. So for those of you who said 7, it's just one little subtlety that we're missing out on. So let's spend some time on it and just discuss. But yeah, that was the last question, guys. So I see someone was struggling to join. Sorry about that. We'll try figure it out. We'll try figure it out for next time. So well done to Chris. You won. So let's check this out. So let's spend some time on this idea just to remind ourselves what's going on with this. So all this is testing is knowledge about the plus plus operator. Okay, the plus plus operator, which we call a unary operator because it only has one argument, right? There's something on the left or there is something on the right. Okay, so prefix or suffix, we would call it. Like either your argument is the suffix or your argument is the prefix. Okay. So this is testing whether you understand what that is doing. So I'm going to show you in 2 different ways, and hopefully that'll make it make sense. So we start by saying int x equals 5. Okay, so we create this variable x and we set its value to 5. Now, what we know is that plus plus in the broadest sense will add 1 to x. Okay. So I'll show it like this first. So I'm going to say x plus plus, okay, x plus plus, and then I'm just going to print out x. Okay, and the people who answered 7, you were thinking along the correct lines in this part. Okay, so we saw that plus plus adds 1 to x, and so you can see I say int x equals 5, so x is 5. I say x plus plus, that adds 1 to x, and then I print out x, and we get 6. Okay, so that's cool. And in this case, x, our argument, was the prefix, right? It came before the plus plus. So now I'm going to put x as the suffix. So x is now after the plus plus. And we'll see that still x is 6 at the end here. So plus plus x, just like x plus plus, added 1 to x. But what's the difference? So you can see in the actual quiz question, I put plus plus before the first time and then plus plus afterwards the second time. So what was the difference? Well, Yeah, so I'll show it in two different ways, and then we'll see. So now, instead of saying plus plus x over here, right, in the highlighted bit, instead of saying it here, I'm going to remove that. Okay? So I've removed the plus plus x, you can see. Okay? So now, when I print out x, you can see it's 5, because I don't say x plus plus. Okay? Now, I'm going to do this. Inside the print statement, I'm going to say x plus plus, all right? X plus plus. So inside the print statements, and I'm going to run this again. Do you see it's still 5? It's still 5. So that x was the prefix here, and it's still 5. I'm now going to make x the suffix, okay? So plus plus x, and I'm going to run this again. And you see x is now 6. Okay, so what's going on here? If x is the prefix, then we see x, we return x before we add 1. If x is the suffix, then we add 1 before we return x, before we see x. The simplest way to understand it, I find, is to read it from left to right. So if you see the plus plus first, then you add 1 and return x. If you see x first, then you return x and then plus plus, okay, and then add 1. Okay, that's the difference. Now, what I want you to be careful about is that still, in both cases, so I'm going to print out x on the next line. Okay, so remember, when I just say x plus plus, you can see it prints out 5. Because x comes first. Ooh, sorry about that, console. What's going on here? All right, yeah. Sorry about that. So you can see that when I just say x plus plus, you can see it prints out 5, right? Because it got to the x first and then it added 1. But what I want you to see is that it still is 6, okay, by the end of that line. So you see here I print out x plus plus, and that prints out 5 because we get to the x and then we add 1. But know that we still do add 1, because when I print out x on the next line, it is 6. You can see this prints out 5, 6. So the only difference is that plus plus x will add 1 and then return x. Okay, so how does this have bearing on the question that we were just asked? So what we were just asked is, so after we created int x equals 5, they went ahead and created int y equals x plus plus, okay? Or actually, I think in the question it was plus plus x, okay? So let's just go through it step by step. Let's see what happens in this case. So I'm going to print out y here, okay? So I print out y. You can see that y is 6, right? Because we said x equals 5, cool. So x is initially 5. We see y, we go to the right. So what are we setting y to? We set y to plus plus. Well, we can't set it to plus plus, but we've seen the plus plus first. So then we see the suffix, we add 1 to x, and then we return x. So we set y to 6, which is 5 plus 1. If we did this in the opposite way around, if we said x plus plus, then what we do is we set y to x, which is 5, and then we add 1 to x. So you can see now y is actually 5. Okay, so you can see how putting the plus plus first does make a difference, but it only makes a difference if you're actually using it on that line. If you're using x on that line, then if the x comes first, x will still be 5. It hasn't added 1 yet to x, reading from left to right. When we get to x here, int y equals x, in a way, it's just reading that as that. The plus plus happens after we set y to x, okay? So hopefully you guys get that. If you're still having trouble understanding that like prefix suffix distinction, then please do post in the chat so that we can spend more time on it, okay? But cool. Otherwise, yeah, that's all I wanted to cover in the quiz. So we've now just got one small topic left to cover in chapter 1, which we already discussed last week. So I just want to finish it off, and then we can move on with what we want. I haven't decided yet whether we should do the knowledge assessments or just start with chapter 2 immediately, but I'll get some feedback and we can decide. Cool. So this is what we were discussing at the end of last week's lecture. Hopefully you guys remember, we were discussing the different kind of errors that can occur, right? So we've seen that while we're programming, a lot of different things can go wrong, right? You could leave out a semicolon. You could accidentally divide by 0. You could access an array outside of that array's bounds, right? Like if the array holds 5 things and you try to access the 6th thing, then it would break. We've seen a bunch of different things can go wrong. You can run out of memory, things like that. So last week we discussed these 5 different errors that can occur. But what I told you, do sort of the names of these errors make sense, right? An out of memory exception is the error that's thrown when you run out of memory, right? Divide by 0 exception is the error that is thrown when you try to divide by 0, right? So these errors make sense, right? They're pretty sensible ones. There are many others. There are definitely many others, which we won't see now. But I do want to, I did just want to introduce you guys to some of the errors that can occur. Okay. Now, the part that we didn't discuss last week is how do we actually handle these errors? And basically, it's just another statement. Okay, it's just another thing similar to an if statement, but for errors specifically. So it's just another collection of words, another statement that we use to handle errors, and it's called a try-catch statement. So how this is set up is you give C# something to try, something to test out. You give it an error to catch, and you tell it what to do if it catches that error. And that's what we call it, catching the error. You could think of it as handling the error as well. Okay, so the error occurs, we catch it, we see that this error has occurred, and then we do something. It'll make more sense when you see it in code, hopefully. So let's just go check it out. Okay, so I'm going to set up a simple example. We're going to say that we are programming a calculator. Okay, let's say we're working at Casio, and currently we're programming the part of the calculator that allows us to do division. Okay, we are programming the part of the calculator that allows us to do division. So we start out simply and we say, all right, I'm going to be dividing numbers together, and we want to handle decimals, right? So 3 divided by 2 is 1.5. Let's set up that first. So we would say something like, we need 2 variables, right? The numerator and the denominator. So we would say double, I'm going to call the numerator n, okay, just because, and we set that to a number. Okay, 3.0. Oh, sorry about that. Some autocomplete there. So 3.0. Okay, makes sense. So I'm just creating a double variable, and you can see it has the decimal places. Okay, and we can do the same for the denominator. So I'm just going to I'm going to call the denominator d, and I'll set that to 2.0. Okay, cool. And then I just want to print out the output to the screen. So I'm going to take the numerator, divide it by the denominator, and print it out. So we'll say console.write, and we're just going to print n divided by d. Okay, n divided by d. Cool. So let's see what happens there when I run this. You can see it prints out 1.5. So our calculator is currently working pretty well. Okay, it prints out 1.5. Now, we're very polite over at our calculator manufacturer. Okay, we're like very polite. And so after the user has typed in the 2 numbers they want to divide, we want to like thank them. Okay, we want to say thank you for using our calculator. Okay, thank you for using our calculator. So I'm going to, on the next line, I'm going to print out thank you for using our calculator. Okay, so I'm just going to thank the user. So I'll say console.write, and I'll say thank you for using our calculator. I'll Thank you for using our calculator. Okay, something like that. And you can see we've now got a nice little system going. You give it two numbers, a numerator and a denominator. We divide the numbers, we print out the output. So here we said 3 divided by 2 is 1.5. And because they're doubles, we can handle decimal places as well, which is quite cool. And then we say, we thank the user for using our calculator. We, tell them, bye, come again, just being polite, right? Cool. So we've created this little system here. But now we want to actually be able to give this to a user, right? But there are a lot of other problems that we haven't yet considered. For example, if you go on like your phone calculator or your computer or on your computer's calculator, like I can open up mine here. If I open up calculator, you can see that. So it's opening up. There it is. So you can see that if I say 3 divided by 2, it gives me 1.5, just like ours does, which is great, right? But if I say 3 divided by 0, it says division by 0 is undefined. It tells me that I can't be dividing things by 0. But what does our calculator do in this case, the one we've just made here? If I try to say 3 divided by 0, so 3.0 divided by 0.0, we get, yeesh, this is horrible, right? We don't want something like this. We want to tell the user that division by 0 is undefined, right? And there are so doubles have like this special way of handling it. You can picture that this could be much more terrible. So let me just make these integers so we can see. So if I run this, you can see that it seriously breaks. Our calculator is just totally wrecked, right? It says errors, exception in user code, system.divide by 0, attempted to divide by 0 at, the user does not want to see this, right? Our user just wants to see a nice, neat little error that says, sorry, you can't divide by 0. That's undefined, okay? So we want to create a set way to handle this error, okay? Like there's lots of possible things that could go wrong, and we want to make sure that we handle them, okay? Another thing that could go wrong, what if the user doesn't set the denominator or the numerator, like they just set it to null? Then you can see our calculator will also break. It will say cannot convert null to int because it is non-nullable. So there's lots of possible things that could go wrong if the user just forgets to type the denominator, right? And you could see we could do this on a normal calculator and the error would be handled nicely, right? If I say 3 divided by, and I don't put a denominator. So I just said 3 divided by, and I hit equals, it just says this expression is malformed. It's not correct. It doesn't mean anything. You need to give me something to divide by, and then it's okay. Okay. So we want our calculator to also be able to handle things neatly like this, rather than printing out a horrible error that no one understands. Okay. So how will we do that? Well, we'll use a try-catch statement. So what we'll do is we'll tell C# to try this out. Okay. So I just type the word try, and I put these curly brackets around what we're trying. Okay, around what we're trying. Let me make it full screen so it might be easier to see. Okay, so I just put these curly brackets around what we're trying. So now I'm just telling C#, hey, I'm not sure, 100% sure if this is going to work because, a lot could go wrong, but just try this out. Okay, and then I say, okay, if something goes wrong, we are going to catch, okay? Catch an exception. And I'm going to call that exception E, all right? And for now, we're going to keep it very general, and I'm just going to tell the user that something went wrong. Okay, so I'll just say console.writeLine, something went wrong. Okay, and we'll also, we're a polite calculator manufacturer, so we'll say, sorry, something went wrong. Okay, so now when I run this, you see last time it gave me this horrible error. Let me just see this. So you see it gives us a horrible error, right? It gave us a horrible error last time. It said, like, if we removed the divide by 0, if we removed the try catch, it would have said system errors occurred, system.divide by 0. It gave us that horrible error. But now it says it tries out the code inside the try statements. It just tries out this little piece of code. And if something goes wrong, it just prints out, sorry, something went wrong. Okay. And we've seen a lot could go wrong, right? A lot of different things could go wrong, but now it's actually handled in the sensible way. Okay. Cool. So, and yeah, there's quite a few ways that we could like break this. So I could say, yeah, but for now we're thinking about properly handled errors. Okay, so you can see that now it actually catches, even though we're dividing by 0, it knows we're dividing by 0, and it says, sorry, something went wrong. Okay, but we want to be more specific than that, right? We want to be more specific than that. So let's sort of experiment with how we could be more specific. Okay, because currently we say something went wrong because I catch all exceptions. Everything that could possibly go wrong, I just print out something went wrong. But what if we know specifically that what is happening is that we are dividing by 0? Then how could we handle this? Okay, so let's experiment with that a bit. The way that we handle this is to say that everything in C# has all the errors in C#, or most of the errors in C# have specific names. Okay, so you can see that there is a system.divide by 0 exception. That is the name of a specific exception. Okay, and I can use that name. So instead of just saying exception E, I could say divide by 0 exception. Okay, divide by 0 exception. And you can see that this currently is working in the exact same way because the divide by 0 exception is the exception that is being thrown. Instead of printing out, sorry, something went wrong, I'll print out E. Okay, so you can see that currently we are dividing by 0 and I'm printing out E, and you can see it says system.divide by 0 exception attempted to divide by 0. So inside this variable E, it is saving the exception that occurred. Okay, so it is catching that specific exception. And so now instead I could say, I could say division by 0 is undefined. Division by 0 is undefined. Okay, like that. Division by 0 is undefined. Okay, and you can see, so now if I give it a valid value, so if I say like 3 divided by 3, that's 1. And you can see it just prints out 1, and then it says, thank you for using our calculator. But if an error occurs, so if I divide by 0, you can see it instead prints division by 0 is undefined. Thank you for using our calculator. Okay, so a lot of different errors can occur. Now, ideally, we want to incorporate everything into our try-catch statement so that it's strong. And that's why C# created this thing called finally. Okay? So at the end of a try-catch, you can have a finally statement. And all the finally statement does is after the code has been tried and the errors have been catched, whatever is in the finally statement will happen. Okay, so you can see it as a way of creating very safe code. So in the try statement, we put what we want to try. In the catch statements, we put the errors that we want to catch. And in the finally statements, we put whatever we want to happen when everything's been tried and all the errors have been caught, the finally statement will always occur. So whether or not an error occurs, the finally statements will run. Okay. And you can catch multiple errors. So because there are multiple different things that could go wrong, right? Like I could either divide by 0 or I could run out of memory, right? So I could say out of memory exception. Or I could have any of these possible errors that we saw last week could go wrong, right? There could be a null reference. We could be out of memory. We could have divided by 0. We could have stack overflowed. We could have accessed an array out of range. A lot of different things can go wrong. And so you can catch any of these errors specifically in catch statements, or you can catch a general error by just saying exception. Okay, exception E. Okay, so you can have multiple catch statements because there are multiple types of things that can go wrong. Okay, and so the finally statement just runs when all of the catch statements and the try statements have been run. Okay, it might, how do I put this? It might seem quite complex, but the general principle is quite simple. And remember the sort of scope on which you can be tested on this, okay? So what do you need to know about this? When we are trying out dangerous code, so dangerous code could be like accessing a website, right? Because you can imagine if you go to a specific website, like if you try to visit a specific page that does not exist on a website, then an error can occur, right? We can say page not found. A lot of different errors can occur when we try to do certain things, right? So you can see that, and other dangerous code could be like connecting to a database, or division, if you're doing division, or if you're trying to access arrays that are of various sizes, okay? A lot of things can go wrong when you're trying to run this dangerous code, when you're trying to perform dangerous operations. So when you're asked, you are writing some code that is performing a dangerous operation, for example, accessing a database. Where should you put this code? You put it in a try statement, because then you're not committed, right? Like if you put it in a try statement, if something goes wrong, the code won't totally crash. You can just handle the error, right? Like you could see when we were dividing by 0 before, our code crashed, like nothing would run afterwards. But here, once we've got a try catch statement, I can just print out our little error message and just continue on my way, okay? Because the error is handled. So when we're running dangerous code, we put it in a try catch statement, okay? Catch statements can be used to catch specific errors, okay? So the errors you must know, you don't have to know them all, and we couldn't possibly teach you them all. There are thousands, okay? Like, I mean, you can see that just on the internet, right? There's error 404 if you haven't found a page, and there are a bunch of other error messages that can be thrown, okay? So there are too many errors for you to be expected to know the name of. The ones you must know are the ones that have clear names, right? Like a divide by 0 exception is obviously thrown when we attempt to divide by 0. An out of memory exception is thrown when we run out of memory, okay? A index out of range exception is thrown when we try to access an index that is outside the range of an array, right? If we have an array with 5 things in it and we try to access position 5, right? So that would be the 6th element because we start counting at 0, then we throw an index out of range exception. So those are the ones you must know the names of. But outside of that, you won't be tested on specific errors, okay? And lastly, you must know that if there's any code that you always want to run, no matter what happens, if errors like come hell or high water, right? Like if errors are thrown, if everything goes smoothly, whatever possibly happens, you always want this code to run. Then you put it inside a finally statement, okay? So what code would we always want to run? Let's say we are opening a connection to a database, and at the end of our code, we need to close that connection to keep everything secure, right? We need to close the connection. Or if we're connecting to a website, and when we finish the code, we need to close the connection to the website. or if we're using space in the computer's memory. And when we're finished running our code, we need to clear that space in the memory so that other things can take its place, okay? So all of those things must always occur. Then we put that in a finally statement, okay? Because the finally statement will always run. C# will make sure that whatever's in that finally statement will always happen, okay? So that's just what this structure allows us to do. It allows us to write safe code. Now, remember, there are a lot of technicalities. Even a professional, like an advanced developer, would have to do a lot of Googling to find out which errors exactly to catch. And so you will not be tested on try-catch to that level of detail. You must just know what the try, catch, and finally are doing, okay? And it makes sense just in terms of the English, right? So try, that's some code to try, and things might go wrong. So it's dangerous code that we're just trying out, like dividing by 0 or connecting to a website. The catch statements are showing us what errors might occur, right? So if this error happens, the catch statement defines what must happen when that error happens, okay? If that error happens, okay? And the finally statement says, okay, finally, after you've tried the dangerous code, after you've caught all of the exceptions, run this. And usually we use it for cleaning up and saying goodbye, okay? Just showing the user that it's stopped now. The error's done, the error's handled, the code is finished, okay? So yeah, that structure is the last thing that we have to learn from chapter 1. I know chapter 1, we did move through it quite fast. There's lots of new information, especially if you're new to programming and just computer lingo in general. But trust me, it does. I think chapter 2 is also quite difficult, actually, not to scare you, but it is, from then on, it gets more manageable because you know all the basics by then. Okay. But yeah, that brings us to the end of chapter 1. I think let's take a 10-minute break now. We'll come back at like 10:05. Just rest our minds and have some water, stretch our legs as well, and then we'll come back and probably, I don't know, you guys must let me know. So I've prepared in the PDFs, in the PDF posted on the WhatsApp group, there is a knowledge assessment. It starts on page 27. So at the end of each chapter, there is a test, basically a knowledge assessment, just to assess you on what you were supposed to learn in that chapter. And so we can either spend time on that, or we can immediately start with chapter 2. So either I'll try to get the polling working, or you guys can just tell me what you guys think would be, because we have done a lot of quizzes. So I think you guys are exposed to many of the questions in the knowledge assessment already. But I'll think about it more while we're on break and decide. But if you guys have a suggestion, then feel free to post it. Okay. So either we jump immediately into chapter 2, which is, especially at the beginning, chapter 2 is quite interesting. It's an interesting way to think about computers and computer science and just, yeah, but we'll see. I'm gonna go have some water first though. Cool, I'm back. Yeah, if you guys have any questions, then now's a good time to post as well. But if not, we will wait till 10:05 before we get started again. Cool. Yeah, sure. I think that's a good, yeah, while I was having my water, I agree actually. Good to just finalize chapter 1 totally. Let me just check the PDF that was posted on the group. I might re-forward it to the group as well, because I know some new people were added. But let me just double check that you guys do have access to the knowledge assessment. Yeah, you do. So the knowledge assessment starts on page 27 of the PDF that was posted on the group. And I'm just going to re-forward it to the group now. Okay, done. So the PDF has been re-forwarded to the group, and the knowledge assessment that we are going to go through starts on page 27. Do actually note it down. Okay, so do like, I don't know, put the question number and just note down the answer so that you can refer back to it, rather than leaving things blank, because then you'd have to come back and watch the video in order to get the thing. So if you just want to revise like 1 or 2 questions, it's definitely beneficial you guys having the answers. Obviously, you would have had a hardcover copy of the textbook, which is the most ideal way of doing it. But with the whole pandemic, I know some people didn't obviously get it. So yeah. So I post someone's asking where they can get access to all the videos and stuff for chapter 1. I added them all to a YouTube playlist, and at the end of each week's lecture, I'll forward the latest video to the group. And so you'll be able to see them all on the YouTube channel. So yeah, don't worry about it. All the previous lectures are recorded, and you'll manage to get through it. Some of my other students from like school students from Roosevelt and Bryanston will just watch the lecture videos on 2 times speed before each new lecture so that they can remember what we were discussing. So it is great to have everything on YouTube, because they say I talk too slowly. I honestly don't think that's the case, but my other students do say that. So they watch it on 2 times speed, and apparently they can actually understand what's going on. So so yeah, don't worry about it. Everything will be uploaded. But I think you guys will actually recognize a lot of the questions, because so the first time I started teaching the course, I didn't do those weekly quizzes, like these Mentimeter quizzes I'm doing. I did no weekly quizzes, and so by the time we got to the end of each chapter, like they would have a good theoretical knowledge, but you can see that just learning the theory doesn't really translate to being able to answer these weird multiple choice questions, right? Because the MTA, like Microsoft, really does word things strangely. So yeah, getting familiar with how to actually answer the questions that you're asked in the MTA is, I would say, probably an important part of the course, right? Is just learning how to answer those MTA questions specifically, rather than learning the generals of programming. But I do like trying to balance it, because if we just did the whole lecture is just test prep, like going through the multiple choice questions, that would be quite boring. And also not beneficial, because obviously you actually want to learn the content as well, rather than just learning towards the test. But it's a difficult thing to balance. Ooh. But actually also the test prep, these slides and the knowledge assessment will actually be a good way to revise chapter 1, like at least get a general overview of it. Because yeah, I guess there's a faster and slower way of doing the MTA course. Like you could just really rote learn all of the multiple choice questions. And it would probably take you less time, but you also wouldn't know much about C# and programming and stuff. But the other way is to actually learn the content that they're being tested on, and then also learn how exactly they ask about it. Which in the long term is probably the more beneficial way of doing it. But anyway, this is more like the philosophy of teaching, I suppose. Cool. So I think we are going to do the knowledge assessment rather than starting immediately on chapter 2. I think it's nice to just, put chapter 1 completely to rest rather than having to come back to this. So let's do this knowledge assessment. You'll find it on page 27 of the PDF. Okay, page 27 of the PDF that I just forwarded to the WhatsApp group now. Fill in the blank. There are 10 fill in the blank questions, 10 multiple choice questions, and 4 scenario questions. Do note down the number of each question and put your little answer there. I will, there are 4 scenarios and they are quite long and involved. So we might just discuss them rather than actually writing the code for them. But in particular, scenario 2, I do want to spend time on, okay? Scenario 2, but we'll get to that later. So let's just start with the fill in the blanks. And yeah, I do want this to be responsive. So I'm gonna wait until I at least get a suggestion from the class about what the answer should be. Cool, so without further ado, let's just get started. So the first fill in the blank question is the and by the way, you don't have to necessarily follow through in the textbook. Most of the questions are given on the slide entirely. So, but yeah, do just note down the answer. So here, question 1 that you would be able to see in your book on page 27. The statement selects for execution a statement list having an associated label that corresponds to the value of an expression. Now, this is why it's important to go through these test prep things. You have been asked this in a weekly quiz and literally the entire class got it right. But when you see it worded like this, it's gross. Okay. So I'll expand upon the wording that they're given here, and hopefully you guys will be able to connect the dots, okay? So they say the statement, okay? So we're talking about a particular statement. So let's think about the statements that we've learned in this first part of the course, in chapter 1. we've learned about the if statement, the switch statement, the try-catch statements. We've learned about the repetition structures. They wouldn't be called statements though. So actually, yeah, those are them. Those are the statements we've learned about. So it's one of those, okay? So which of these statements do we give a list? Okay, so we give it a list of things. Each one has what we might call the label, okay? So each member of this list has like a specific thing that it does, like a specific thing that it's accounting for. And the expression we give to the statement, so the little thing we put in the normal brackets after the statement, is compared to each thing in our list. And if it's equal, if it's the same as that thing in the list, then something occurs. Okay, so think about the statements we've covered. Which statements do we give a list of values that it must compare the expression to? Does anyone know? And remember that, because it might seem complicated if you start like in the woods, if you like, but remember that there are only a few here. So the if statements, do we give the if statements a list of values? No, we give it a condition. The try-catch statement, do we give it a list of values? No, obviously the try-catch statement has nothing to do with this, right? That would only be the answer if we were being asked about errors or exceptions or something. The switch statement, do we give it a list of values that it tests if the expression corresponds to? What do you guys think? I am kind of almost suggesting the answer, so I think I've given this one away probably too much. But you can, hopefully you can see that the wording is the more complicated part of this question. So this first question, the answer is switch. Okay, the switch statement selects for execution a statement list having an associated label that corresponds to the value of an expression. Okay, so when we said north, east, south, west, that is what they are referring to here as the statement list with associated labels. The expression is the little direction that we specify. So, right, we said N, and then it must print out north. So it compares through our list of like N, S, E, W. It compares that, compares the expression to that list, and then it selects for execution when the value of the expression, N, corresponds to the value in the list. Okay, so it's a very weird way of wording it, but hopefully you can see that the question itself is not difficult. What's difficult is how it's being worded. Okay, so you just have to learn to think in this kind of way. Okay, so I'm not going to give away the next one. Let's just see how you guys do on it. Okay, the loop tests the condition at the bottom of the loop instead of at the top. This one I would want you to be able to answer. Can anyone post in the chat or say over the mic, which of our 4 repetition structures is this talking about? The loop tests the condition.
Is the do-while loop.
The do-while loop, precisely. Okay, so quite a nice one. But remember, if you had just been taught the do-while loop, right? Like if I had just taught the do-while loop and we had the do and the while and then the condition, and then you get asked this question, like it's tested at the bottom of the loop instead of at the top, that's honestly a pretty weird way of describing a do-while loop, right? It's like only one way of many possible ways. And yeah, so like the wording is what makes these questions more difficult. It's not that the question themselves is hard. Okay. The only operator that takes 3 arguments is the, okay, we did discuss this briefly. We might, I think actually on this one, we'll spend a little bit more time since we do have a whole hour to go through this knowledge assessment. The answer to this question is actually on page 10, okay, of the PDF. So if you guys flick over to page 10 and just read like the first little bit, and yeah, I'll wait until someone tells me which operator is the only operator that takes 3 arguments. Okay, so just head over to page 10 of the PDF and tell me what you think. And Cool. That was very quick. Okay, so someone says the ternary operator, and yeah, that is correct. I think it's worth maybe. So you see, here we could stop, right? We could say like, okay, the ternary operator is the only operator in C# that takes 3 arguments. And if you're ever asked this question again, you'll just remember ternary, because ternary is kind of related to 3, right? We have unary, which is 1, binary, which is 2, and ternary, which is 3. So you would sort of remember that this is happening, but rather than just leaving it at that, I actually want to, discuss the ternary operator. Okay, so this is what I was saying earlier, where like there's 2 ways you could do this. But yeah, I prefer going more into detail rather than just leaving it as a blank idea. So the ternary operator is basically an if statement. Okay, it's basically an if statement. So I'll show you it. If you're interested, if it gels with you, then that's great. If not, remember, all you have to remember is that the ternary operator takes 3 arguments, okay? So what does the ternary operator look like? You can see it on page 10 in that like whole table that they have. Conditional ternary, you'll see it looks like this. It's a question mark and then a colon. Okay? That is the ternary operator. That is what it looks like. And yeah, all this is basically a more complicated way of writing an if statement. Okay, so what do we, so I'll say firstly, the first thing to explain, the ternary operator takes 3 arguments, right? We've seen unary operators like +1, where it just takes 1 argument as like the prefix or the suffix. Okay, that's a unary operator, it means 1. We've seen binary operators that take 2 arguments, like all our mathematical operators. Like plus will take an argument on the left and it'll take an argument on the right, right? It takes 2 arguments, argument 2, argument 1, and it takes the thing on the left and it adds it. This is literally just a plus sign, right? It just adds it to the thing on the right, okay? So we've got all these different operators, unary and binary. The ternary operator takes 3 arguments, okay? It takes argument 1 before the question mark, argument 2 after the question mark and before the colon, and argument 3 after the colon. Okay. That is what the ternary operator, that's why it's called ternary. It takes 3 arguments and you can count them, right? And what this is actually used for is as a faster way of writing an if statement. Okay. So I'll just give you I'll give you an example and we can just see how it works. So I'm going to do something with an if statement and then I'll show you how I would do it with the ternary operator. Okay. Just so that you know what the ternary operator does. But remember, the main thing you guys actually need to remember about it is that it uses 3 arguments. Okay. So don't get too bogged down in the strict technicality yet. If you went on and did an MCSA, then obviously you would have to think more about how to actually do this on like a technical level. But for now, we're learning, right? Okay. So what I'm going to do is if x is greater than 5, I am going to print out x is greater than 5. Otherwise, I'm going to print out x is less than or equal to 5. Okay, so I'm just going to ask the question, is x greater than 5? If it is, I'm going to print out console.write x. Okay, else I am going to print out, I'll say, sorry, we said I would print out x is greater than 5. X is greater than 5. I'm just going to say greater than 5 for short. Okay, greater than 5. Okay, and in the other case, I'm going to say console.write less than or equal to 5. Okay, so this is a pretty simple if statement, right? I just set the variable x and I ask a specific question, right? Now, the ternary operator is pretty easy to understand in this context, actually, because it actually looks similar. So you can see in the if statement, we ask a question. We ask a question over here, like x greater than 5 or whatever. We we say inside the first part of the if statement, we say, if the question is yes, if the answer is yes or true, if the answer is yes, and by yes, we also mean true, right? And we can also see, I'm sorry, our neighbor sometimes decides to do some early morning carpentry on Saturday mornings, which is very considerate of them. And then in the else part of the statement, we have if the answer is no/false, okay? The ternary operator works in a very similar way. So we just ask a question, and you can imagine the question is followed by a question mark, right? So I say, is X greater than 5, question mark? Okay, so that's me asking the question. I put the answer if true. I'll say console.write. I'm just going to print out greater here, just for short. Greater, and then I put a colon and just say console.write less. So before the colon is the answer if true. After the colon is the answer if false. Okay. So the ternary operator is just like writing an if statement, but on one line. Okay, that's what it's used for. Okay, so I just wanted to discuss. And apparently, let me just see. Only assignment call increment decrements awaiting. Okay, cool. So the issue here is that you can only do like assignments. So I'll say x plus plus or x equals x plus 1. You can only do assignments in this case. So it is quite limiting, but this is sort of what it's used for. Okay, so if false, if true. Okay, so that's what the ternary operator does. All right. So let me just see. We can say like, I'll do it this way. Y equals, is x greater than 5, then it equals y, otherwise it equals 0. Okay, and then I'll print out y. Sorry, I'll explain now. It's just like it's a little bit technical how you have to do it. Okay, so what did I do here? So what I've created using this ternary operator is essentially an if statement. So what this will do, it says int x equals 6. Okay, I then say int y equals. Now we are setting it equal to this complicated thing here, and it's a mess. Okay, the ternary, it's pretty gross. You would never use this. Okay, you would never actually professionally program like this. I'm just showing you so that you know what the ternary operator does. Okay, we ask the question, is x greater than 5? Okay, if it is greater than 5, then we're going to set y to be x, and otherwise we'll set it to be 0. So you'll see if x is equal to 6, so x is currently equal to 6, then x is greater than 5, and so y becomes x, okay, which is 6. So you can see that y is 6 at the end. If I made y equal to 4, then you'll see that at the end, if I made x equal to 4, then at the end y is 0. Okay, so for those of you who get it, we're basically just asking a question. We say what we want if it's true and what we want if it's false. Okay, it's not too bad, but that's what the ternary operator is for those of you who were interested. But the important thing to remember is it takes 3 arguments: something before the question mark, the answer if true, and the answer if false. Very similar to how an if statement works. Okay, cool. On to the next question. Sorry about that brief sort of aside. The loop is the most common way to iterate through items in a collection. The loop is the most common way to iterate through items in a collection. What do you guys think? Well, yeah, correct. Okay, so I'm glad. So Clark just posted in the chat for each loop, and yeah, that is correct. Okay, so again, why is this a little bit weird, maybe the first time you see it? Well, number one, we're used to referring to what they here are calling a collection. We're used to more referring to as an array, right? So there are, like, particularly in chapter 1, we only really refer to arrays, not like a general collection yet. So yeah, the question itself is not difficult, but if you're uncomfortable about the wording, then it could have been more challenging. Cool. Next question. On a 32-bit computer, a variable of the int data type takes bytes in memory. So they are asking for bytes here. Okay, so what do we think, guys? Again, see, you've seen similar questions. But this one is subtly different from one that you have been asked before. Cool. Cool. Okay, so we've got a few options here. So someone did say 4, and someone says 2. Interesting. Okay. Cool. So I think we have the time, so let's spend a little bit of time on this. So we know that it is 32 bits, right? We've seen that question before. Okay, an int data type is 32 bit. Okay, another person says 4, good stuff. So the int data type is 32 bits, all right? So the main thing is just transferring from bits to bytes. And there are 8 bits in a byte, okay? 8 bits in a byte. So we know that the int data type is 32 bits, and ideally you should try to remember this. There is a simple, so you can see this is all on page 9 of the PDF, okay? Page 9 of the PDF gives you the list of data types that we've seen before, and it gives you the sizes. Now, there is maybe a slight trick to remembering this, okay? In that you only have to remember the smallest things, okay? So for example, a byte is obviously 1 byte. There is a data type in C# called byte. You can see when I type byte here in RexTester, it's highlighted in purple. RexTester C# does know what byte means, okay, byte. And the byte data type is obviously 1 byte, okay, it's 1 byte. Short is 2 bytes. Short is what we use to hold short numbers between minus 32,000 and positive 32,000, if you remember. So short is 2 bytes. A short is 2 bytes. Remember, I'm not writing code here. I'm just writing for us to understand. So I'll put it in a comment instead. Okay. So I'll say 8 bits in a byte. So a short is 2 bytes. That's the shortest number we can hold. Okay. Or yeah, shortest proper number we can hold. Shortest integer, I'll say. Short is 2 bytes. We can see that int is 4 bytes. Long is 8 bytes. Now you can see that that's a fairly easy pattern to remember, right? It's doubling each time. Okay, and you can see the sort of the same is true. So if we want to hold decimal places, we can store them in a float, which is 4 bytes, or we can store them in a double, which is 8 bytes. Double the precision of a float. So again, the sizes, it might seem like a lot to remember, but it is quite easy to get into your head, right? It's like, it's not too bad of an idea, okay? And you can see even with like a char, that might be a little bit weird, but like a char, like a single character is 2 bytes, okay? Is 2 bytes. And a string is just an array of chars, basically, or list of chars. But we'll talk about that more one day in the future, okay? For now, yeah, these are the sort of sizes that you should remember. Here we're being asked about the int data type. How many bytes is it? It's 4 bytes. If we were asked about how many bits it is, we would say 4 times by 8, right? Because there are 8 bits in a byte, and we get 32 bits. Okay. So it's 32 bits in an integer. Okay. So yeah, that's just, it's basically theory knowledge, but it's not too bad to remember, I don't think. So yeah, the answer here is 4. On to the next question. To access the first element of an array, you use an index of So how do if I'm trying to access the first element inside my array, what index do I use? Okay, that was, someone answered quite quickly. That's cool. I'll leave it open for a little bit more for if anyone else wants to answer. So how do we answer the, okay, so cool. 2 people have said 0 now. That's cool. And that is correct. Okay. So this is just asking, where do we start counting, right? We start counting at 0. The first item in the array is 0. For those of you who maybe still are a little bit hesitant about answering that one, it's pretty easy when you see it like this. So if I create an array here, like with 4, 3, 2, 1, right? And I want to print out 4. Okay, I want to print out the first item in this array called numbers. I would access numbers in position 0. And just to remind you, the number here, this 0, is called the index. Okay, so if I run that, you can see it prints out 4 because the first part of my array starts at 0. This might seem a little bit arbitrary and weird to you, like why did they start counting at 0? It just seems silly, but we'll see why. And in chapter 3, we spend a lot of time on this, and you'll see why it makes so much sense that we start counting at 0. It's because when we're talking about computers, we are talking about memory, right? Space in memory. And so starting at 0 makes a lot of sense in that context, which you'll see later. Okay, on to the next question. 7 is a programming technique that causes a method to call itself in order to compute a result. So is a programming technique that causes a method to call itself in order to compute a result. Okay. Oh, yo, that was quick. That's good. Yeah, that's good. The answer here is recursion. Okay, this is just by definition, really. If you remembered our lecture on recursion, then this one probably shouldn't be too bad. We will discuss the Code Wars kata either this week. Maybe I'll give you guys an extra week to do it. But yeah, we were doing the recursion Code Wars kata, and recursion will come up in different points over the course of the course. Okay. Are data fields or local variables that cannot be modified. Okay, I spent literally so little time on this that I think we might have to discuss it again in order for anyone to get it. What, Clark? Where did you? Okay, wow, yes, that's actually correct. Well, here we would say const, okay, because that's the keyword we use. But yeah, const stands for constant, so yeah, 100% constants. So that's great, actually. But yeah, I didn't spend enough time on this to expect people to know it. So I am just going to take, we're going to take a little bit more time on it. Okay. So it's a fairly simple idea, right? Here, if I have int x equals 6, right? Int x equals 6. So that's normal. This you should be comfortable with. We've got int x equals 6. We've created a variable here. We've set its value to 6. Okay. I can then say like x equals x plus 1 or x plus 2 and print out x, right? So let me just do that just for the sake of the example. Okay. So you can see I created a variable x and set it to 6. I add 2 to the variable x, so x equals x plus 2, and then I print it out. And we've got 8 at the end. So I mean, because 6 plus 2 is 8, fairly straightforward, right? But there are some times when I'm programming something that I don't want to change. For example, you guys have heard of pi before, right? So double pi equals, so you know what the mathematical thing for pi is. It's like 3.14159, and that's about as far as I can go, okay? And so you could see that when I'm working with pi, like let's say I was writing a calculator again, for example, when I'm working with pi, I don't want you to be able to add 2 to pi, right? I don't want, pi should never change. Pi is constant, it's fixed. And so how I tell C# that I want something to be constant is I just say const. Okay? I just put the word const in front of it. It stands for constant. And so now it says constant double pi. And so now when I try to say pi equals pi plus 2, it says, look, you can't do this. It's constant. You can't add 2 to pi. So it gives me that error. And so I'm no longer allowed to plus 2 to pi. Pi is now not modifiable in my code. It is a constant. Okay. So that's why we use constants. If we want something that will never change throughout our code, we just make it constant. Okay, if we need some value that mustn't change. Okay. So yeah, it's not too bad of an idea, and yes, but I couldn't. We discussed it so briefly on that one slide that I couldn't expect you guys to know it. So, but now you can be expected to know it. Okay, so const are data fields or local variables that cannot be modified. So if you say const in front of it, then it can't be modified. And yeah, it's short for constants. I think if you said constants in the test, they would accept it. So you can say either. But the keyword we use actually in C# is const, okay, rather than typing constant. You can see that programmers are very lazy, like just sacrificing those last 3 characters. Okay, 9. When an algorithm involves a large number of conditions, an is a compact and readable format for presenting the algorithm. Okay, compact and readable format. So we've seen similar wording being used to discuss these ideas before. So I'll maybe give some hints because it's maybe a little bit vague. So we can say, we have an algorithm, all right? I want to display the algorithm to you guys. So how, okay, cool. So Clark says decision table, which, so yes. Cool, but I want to discuss a little bit more. So we discussed 2 different, remember, this could only be one of 2 possible things. In our very first lecture, we discussed decision structures, what we call decision structures, and we had flowcharts and decision tables, okay? If you are asked for a neat, understandable, graphical representation of an algorithm, you would say flowchart, okay? Decision tables are specifically used when we have a large number of conditions, okay, where there are like with the ATM example, there are lots of possible combinations, and it could be pretty overwhelming if you're trying to think about all of these conditions. But it is, you know, but once you've displayed it in this decision table, it's nice, it's readable, it's compact. Okay, and so compact and readable, that's a clear sign that they're talking about decision tables. Okay, cool. Nicely done. Is a graphical representation of an algorithm. Okay, so I literally just told you guys the answer to this one, so I'm just gonna, I won't waste your time on it. So a flowchart is a graphical representation of an algorithm. Okay, and that is all the fill in the blanks. If you manage to get like all of these, then you're pretty good on chapter 1. Like you'll find most chapter 1 tests pretty straightforward if you manage to get all of these. Okay. Next, though, it does get, the multiple choice questions are also interesting and very different. So we'll go through them as well. But like I said, we'll probably not spend too much time on the scenarios, but you're welcome to either WhatsApp me about them or spend some time on them yourself, because they are a bit long to spend lectures on. You could do like a little mini project on each one of them, really. So hopefully the Code Wars cutters are kind of replacing those scenarios for us. Okay. Write the following code snippet: int n equals 20, int d equals n plus 5. Ooh. What will be the value of d after this code snippet is executed? Okay. So there are a few ways you could approach this. You could actually type this up in Rex Tester, obviously. That would be one way. And just test. But remember that in the actual final exam, the MTA exam, you will not have access to code. Okay, Mabel says 26. Nice. Okay, do we have any other suggestions? But yeah, that's where we're thinking along the correct track there. So we're thinking along the correct track there. It is a little bit, it's a little bit strange though. So we have to be a bit careful. Okay, we have to be careful about how we read this n++. Remember, what does it mean for this to be the prefix? What does it mean for it to be the prefix? Okay, I think we have spent time on this today already. Okay, so yeah, so it's 25, but it is confusing. There's so many ways that they can phrase this question. Again, what this is testing fundamentally is whether you know this plus plus thing. Okay, whether you know this plus plus idea. So we are gonna let's just check this out in code, and we'll just discuss it a bit more. Okay. So again, yeah, we'll see. So int n equals 20, int d equals n plus 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 5. Okay. Console.write. I think this is one of the more complicated ways. I did give you a question like this in the quiz where I was testing the difference between prefix and suffix. This is probably one of the most complicated ways they can ask this question. So you see when we put that into C#, it gives us 25. Okay. Now, as you can imagine, if I instead moved the suffix, if I made n the suffix instead of the prefix, it would now be 26, right? So we'll just wait for C# to run. You can see it's now 26 because the n is the suffix. Okay. But let's just see what's going on here, just because it is a bit strange. Okay, so we say int n equals 20. Okay, this first line we understand, we don't have to discuss that anymore. Int d, so we're creating a variable, equals. Okay, the equal sign takes the thing on the right and saves it in the thing on the left. So we are analyzing this thing on the right. Okay, we just need to figure out what the value of this thing on the right is, and then we'll know what d's value becomes. Okay, so how do we evaluate this? We've got two operators here. We've got a unary operator, plus plus, and we've got a binary operator, plus. So we start with the plus sign, okay? The plus sign will take the thing on the left and add it to the thing on the right, okay? That's all it'll do. The 5 is pretty simple. We know what 5 is, so we're gonna add 5 to whatever's on the left, okay? What is on the left? On the left, we have n, and we see n first. N is the prefix. So n is 20. Okay, n is the prefix, so it's 20. We read 20. We do still see the plus plus, so we will add 1 to n. And you can see if I say console.write n, and I'm just going to make this a right line, so it's on the next line. You can see if I say console.write n, n is now 21. N is 21. The plus plus does add 1 to n, but we read n as 20 first, okay, because it's on the left. So just make sure you read from left to right. N, okay, it's 20, plus plus, we add 1 to n, but we've already read the 20. We've already read the 20 when we plus plus. So then we say 20 plus 5 and save that into d, so d's value is 25. Okay, so again, there are a lot of subtleties like this, but once you start reading the operators in this very technical, rule-based way, okay, then you'll start to get it more. Okay, but I mean, this is also a lot down to practice. As we go through the course, this whole plus plus thing will come up more, and so you'll become more sort of in tune with the way C# reads. Okay. Question 2. Write the following code snippet. Okay, and they give us this little code snippet here. How many times will the while loop in the code snippet be executed? Okay, interesting. So the options they give us are 0, 1, 4, and 5. Okay, someone says 4. Ooh. So remember, there are a few tricks that you can use to do this, especially a loop this small. Okay, so I did give you the equation, right? End minus start, and we do remember end minus start, and you would say end minus start plus 1 if it was less than or equal to, but it's not less than or equal to here, right? But let's think about this. So we start at 1. We say int I equals 1. We're starting at 1. So we run once for 1, right? 1 is less than 5. Okay. We then add 1, so it's 2. Okay. So I is now 2, and we run again. 2 is less than 5. we add 1. Okay, we run again for 3 because 3 is less than 5, and we add 1. We run again for 4. We've now run it 4 times, and we add 1. We're now at I equals 5. Do we run this 5th time? No, because I is now 5, and 5 is not less than 5. 5 is equal to 5. Okay, and so you'll see that the answer here is 4. Okay, let's play around with this loop thing because they do ask this frequently. So I do want to, it's worth spending some time on. Okay. So let's try this out quick. We might not finish the knowledge assessment today, but I'm kind of okay with that. We can always finish it next week. Okay. So there are tricks to remembering how to analyze these loops, but the best way is to just sort of, again, practice. Practice makes perfect. Okay. So we can see when we run this, it'll print out 1, 2, 3, 4. 1, 2, 3, 4. Okay, so what's going on here? We started 1 is the key thing here. So, and also this is not less than or equal to, it's less than. So if you just want to remember it according to the little trick I taught you, which you can use, you just have to be very careful. You can just say end minus start, okay? This, again, only works if the end is larger than the start, so you're not moving downwards, okay? And it also only works if this is not less than or equal to. If it's less than or equal to, then it's actually end minus start plus 1, okay? So you have to be sensitive to those little tricks, but end minus start is a pretty good way of approaching it when it's less than and it's moving upwards, okay? You can say end minus start, and you could see we would say 5 minus 1 is 4, okay? And it does run 4 times. That's how much it executes. How many comparisons does it do? It does the number of times it executes plus 1 number of comparisons, right? We check, is 1 less than 5? Is 2 less than 5? Is 3 less than 5? Is 4 less than 5? Is 5 less than 5? So we're doing 5 comparisons, and we're executing 4 times, okay? So that's just the way we analyze these loops. And you can see there's a few ways we could switch it up, right? If instead we were starting at 3, we would now run twice, right? We would run for 3 and we would run for 4, okay? And you can see that goes 3, 4. If this was less than or equal to, we would now run 3 times, okay? Because we'll run for 3, we'll run for 4, and we'll run for 5, okay? And you can see that it runs for 3, it runs for 4, and it runs for 5. See, 3, 4, 5, okay? And there's other ways we could switch it up as well. We could say, is I equal to I plus 2? So now we're going up in 2s, which is quite hectic, right? And you can see this can become very, very confusing. Okay, so now we would run for 1, and we would run for 3, and we would stop on 5. So what is this? It's end minus start divided by 2. We're running twice. Okay, we'll run twice in this case. So yeah, there are a few different ways to analyze these loops. It's mostly just maths knowledge, I suppose, like how many integers are greater than or equal to 1 and less than 5, right? That's basically the question you need to answer. And yeah, cool. I hope we've spent enough time on it. It is, again, it is something you get better with practice, okay? Okay, another interesting question here that, again, we discussed very briefly, but that's why it is good to go through these knowledge assessments, because we can go more specifically into how they ask questions. Because you can see on this particular question, they will be testing an if statement, okay? But they're testing a very particular case of an if statement that's very infrequently used, okay? So it would be a weird thing to teach if you were teaching C#. But if you're teaching for the MTA, this is an important thing to get. Okay, so we write out the following code. So we create number 1 and we set it to 10. We create number 2 and we set it to 20. Okay, so we've got 2 variables here, number 1 and number 2. Number 1 is 10, number 2 is 20. We ask a question here. If number 2 is greater than number 1, so is 20 greater than 10? That's true. Okay, 20 is greater than 10. So we say console.writeLine number 1. And actually, let me just double check in the book because I think we've got a little problem here. Yeah, okay, let me just fix that quickly on the slide. Oh, wait, I'll answer the question and then I'll fix it just so that I don't give away the answer too quickly. So number 1 is supposed to be in quotation marks. Okay, so it's supposed to print out the string, not the variable. Okay, and console.writeLine number 2. Okay, all this is testing. Notice that the if statement does not have curly brackets after it. Okay, and that's basically what this is testing. So the answer here is number 1, number 2, but let's go through it in code and actually see what's going on. Okay. Yeah, and I think this will probably we'll probably get to one more question after this one. Okay, int number 1 equals 10, int number 2 equals 20. Okay, by now you guys will get those first 2 lines very well, right? You know what those are doing. We're creating 2 integer variables. Okay, you even know how much space they're taking up in the computer's memory. Hey? We then have an if statement. Now, usually how we would write an if statements is we would put the curly brackets afterwards. And you always should do this, okay? Because this is good programming. Putting the curly brackets there, it's neater, it's just better, okay? But what they're testing here is like a special case, right? They're trying to make it difficult. So we see here they say number 2 greater than number 1, and we know what that's asking. It's just going to say is 20, which is what number 2 is, greater than number 1, which is currently 10. And you can see that that's true, right? 20 is greater than 10. So if there were curly brackets, we would run whatever is here. There are no curly brackets in this case, though. In this case, all they do for us is they say console.writeLine, and they say we're going to print out number 1. Wait, they say number 1, right? Yeah. We're going to print out number 1, and then we're going to print out number 2. Okay. But they have no curly brackets, and they make it even a little bit more difficult by putting these on the same line. Okay. I mean, on the same like level of indentation. And they're asking you, what is this doing? Now, usually you would look for the if statement's curly brackets, right? You would look for the curly brackets of the if statements. And then you would say, okay, if it's in the if statements and it's true, then it'll print. If it's outside the if statement, then it'll obviously also print. Okay. And we can see when we run this, it does print number 1 and number 2, which is pretty safe, right? Like even if you didn't understand what was going on here, you could still have gotten to the fact that this would print number 1 and number 2. If you look at the other answers, number 1, why would, like, if we're looking at the if statement, okay, the question here is what is inside the if statement, but the if statement is true anyway. So it's always going to be printing whatever's inside the if statement. It's always going to be printing number 1 and number 2, okay, whether or not they're both in or one's in. Number 2, it could never skip number 1 here because the if statement is true. And number 2 could never print before number 1. So by deduction, you could have gotten to number 1, number 2. But I want to explain so that you can understand on a more technical level. But yeah, by deduction, you could have been able to get to C, but we'll see now in the code, okay? So what's going on here? The first thing to explain, if there are no curly brackets, then the first line after the if statement, only the first line, is taken as being inside the if statement, okay? If you leave out the curly brackets, then just the first line, so up to the first semicolon, so you can see there's a semicolon here, up to that semicolon is taken as being inside this if statement because there are no curly brackets, okay? Obviously, if you have curly brackets, you can have as many lines as you want inside an if statement, but if there are no curly brackets, then C# will just read it as if the first line after the if statements is inside the if statements. Okay, so that's just what it means if there's no curly brackets. But again, that's a bad way to write code. You should always put the curly brackets. And so we can demonstrate this, okay? I'm gonna make number 1 30. So now this question is false, okay? Number 2 is 20, number 1 is 30. 20 is not greater than 30, so this is false. And you'll see it'll no longer print out number 1. When I run this, you can see number 1 is not printed out because number 1 is inside the if statement, okay? Number 1 here is inside the if statement. Number 2 is not inside the if statement. It will always print, okay? Are you okay with this idea? It's the same as if statements. It's just that without curly brackets, there's this special way of reading them, okay? And it's just to trick you, obviously. So it is a multiple choice test, so the only way that they can make it difficult is by tricking you. So that's the problem we're running into here. But yeah, if you guys are okay with that, let me know. If you want to discuss this even more, then we can. But for now, I think let's go on to the next question, and this will be the last one we do for today. In a switch statement, if none of the case statements match the switch expression, then control is transferred to which statement? A, break, B, continue, C, default, or D, return. This one I would want you to be able to get, even though they're wording it funny. Does anyone have any idea? Which one would it be here? Okay, Clark says defaults. I'm gonna leave it open for a little while longer before I answer, just in case anyone else wants to say. Okay, I'm gonna take that as a positive sign that everyone here is agreeing with Clark. And yeah, so default is correct. But again, what might have made this question difficult is just this idea that just the way it's worded, right? So we're in a switch statement. We know what switch statements look like. There's a bunch of cases, and if none of the cases are true, then we go to the default statements, okay? Default case. So if none of the case statements match the switch expression, then control is transferred to which statement? And in a way, you can see this as just the definition of the word default, right? Like nothing is, we're not sure. So the default case, by default, we do this. Unless we get some other information, then we do this by default. And so yeah, defaults is correct there. I think actually we did move through that one quite quickly. Let's see, what is the next question about? The next one is interesting. Okay, we literally just discussed this. So you need to write code that closes a connection to a database, and you need to make sure this code is always executed regardless of whether an exception is thrown. Where should you write this code? Within a try block, within a catch block, within a finally block, or within the main method? Nice. Okay, so someone's answered. I'll leave it a bit more so we can see what do we think. Anyone? What do we think, guys? Where would we put this code? We want it to always run. Okay. Let's see. Maybe I hope that you guys just aren't answering because it's too easy. But yeah, so the answer is C. Okay. So remember, we have this idea of try, catch, finally, and someone did say this. Chris did say C. So this is correct. So A, B, C. We've got a try, catch, and a finally block. The try is just some code to try. The catch is all the errors, all the exceptions that we must catch, like if the database connection fails or whatever. And the finally block is what will always be run. Regardless of what happens, come hell or high water, that code in the finally block will be run. Okay, and that's what that's telling C#. Whether or not an error occurs, whether it does occur or doesn't occur, Like everything could go perfectly, the stuff in the finally block must be run. All the errors could happen, the stuff in the finally block must be run, always. Okay, so yeah, that's for that one. We can just check out the next one. Yeah, it's not too bad either. You need to store values ranging from 0 to 255. You also need to make sure that your program minimizes memory use. Which data type should you use to store these values? Interesting. 0 to 255. Okay, someone's already gotten it again, so that's cool. I'll leave it open-ended for a little while. There are, maybe they did put a little trick here, right? So short can hold from minus 32,000 to positive 32,000. So the short data type is the shortest integers we can hold. But this is not even integers. We don't even need negative numbers here. 0 to 255. I think, actually, yeah, since we've got a minute left, the answer here is byte, because a byte is 8 bits, and 8 bits can hold exactly 0 to 255. But I want to show you guys why this is quickly, just to explain the logic, and then we'll call it for today. Okay. So I'm just going to switch over to Rex Tester to explain this quickly. Okay. So I'm going to give myself some space here, and we'll say that, yeah, I'll type it out quite quickly, and we'll just, and hopefully you guys will get it. Okay. So 0, 0, 0, 0. This is 0. Okay. This is 4 bits, right? 4 bits, because each of these can be 0 or 1. Each of these is a bit. Okay. If we set them all to 0, that means 0. Okay, we've got 4 bits here, so half a byte, if you like, right? But there's 4 bits. Okay, 0, 0, 0, 1 would be 1. Okay, 0, 0, 1, 0 would be 2. 0, 0, 1, 1 would be 3. Okay, so I am going to take up a little bit of extra time. Hopefully you guys don't mind. 0, 1, 0, 0 would be 4. 0, 1, 0, 1 would be 5. 0, 1, 1, 0 would be 6. 0, 1, 1, 1 would be 7. 1, 0, 0, 0 would be 8. I am going to go the whole way. 1, 0, 0, 1 would be 9. 1, 0, 1, 0 would be 10. 1, 0, 1, 1 would be 11. 1, 0, 0 would be 12. We're almost there. 1, 0, 1, 1, 0, 0, 1 would be 13. 1, 1, 1, 0 would be 14. And lastly, 1, 1, 1, 1 is 50. Okay, we did it. Okay, this is 4 bits. Now, as you can see, there is nothing more I can hold here, right? Nothing more. I can't, right? I've used every single possible combination of 4 zeros and 1s. There are 16 of them. I can only represent 16 numbers in 4 bits. Okay. Now you can picture, I'm not going to write it out, obviously, because we would be here all day. But with a byte, we have 8 bits, right? So 1, 2, 3, 4, 5, 6, 7, 8. This is equal to 0. And like that same line, right? If I make that 1, this would be equal to 1. And you can picture, we could go through this counting process, okay? We could count up, okay? But this time we have 8 bits. We have double the space, or more than double, actually. We've got plenty of extra space here, okay? If we did this process, so if we counted up, if we went ahead and we continued counting for long, eventually we would get to 1, 1, 1, 1, 1, 1, 8 ones. This number in 8-bit binary is 2555. I mean 255, 255. So 1 byte can hold 255. Okay. Can hold anything from 0 to 255. So for anyone who, if the sizes of these different data types weren't making sense, hopefully this helps you understand it a little bit more. And I think we'll call it there for today. So we'll start with question 7 next week and just finish off this knowledge assessment and then get started on chapter 2. But yeah, we'll call it there for today. Thank you for coming, everyone. Enjoy the rest of your weekends. Enjoy your weeks as well, and see you next week, Saturday. Hey? Thank you for coming. Feel free to WhatsApp me. We'll just continue with the kata we were doing last week. It was recursion number 1, and it's a 7Q, okay? But yeah, you can spend some time on it. I did kind of, if you watched the recording of the last week's lecture, we did discuss it in quite a bit of detail, but you feel free to WhatsApp me as well if you're having trouble. Okay. Cool. But yeah, thank you guys. We'll call it there for today. Cheers, cheers.